Hello everyone, I am Dr. Sanjay Kumar Shrestha, cardiologist. Let me begin by asking a simple question. What causes heart attacks? Most people say cholesterol. What causes diabetes? Sugar. What causes high blood pressure? Salt. What causes obesity? Fat. And what causes cancer? Bad luck, genetics, or simply getting older. But what if I told you that these are only part of the story and many of these diseases actually begin 10 to 20 years before they are diagnosed? Your HbA1c may be normal, your blood pressure may even be normal, yet a hidden metabolic process may already have begun. That process is called insulin resistance. Today, I want to explain why I believe understanding insulin resistance may be one of the keys to preventing many modern diseases. First, let me explain what is metabolic process or metabolism. The word metabolism simply means everything your body does to produce, store and use energy. Our body is an extraordinary machine. Every second, approximately 30 trillion cells require energy. That energy comes from the food we eat. When the systems that regulate energy become disturbed, we develop what doctors call metabolic diseases. These include obesity, type 2 diabetes, fatty liver, high triglycerides, high blood pressure, and elevated uric acid. Over many years, these conditions greatly increase the risk of heart attack, stroke, kidney disease, and even many different cancers. Although each disease has its own causes and treatments, they frequently occur together and often share underlying metabolic abnormalities, particularly visceral obesity and insulin resistance. But to understand why metabolic diseases have become so common, we first need to understand how our metabolism evolved. For nearly 2 million years, humans lived as hunter-gatherers. Food was unpredictable. Some days our ancestors ate large meals, some days they found nothing. Famine was more common than feast. Now, feast is more common than famine. To survive, evolution designed a remarkable energy storage system. The immediate energy came from sugars in the blood that normally came from eating carbohydrate meals. Extra energy was stored first as glycogen in the liver and muscles, and much larger amounts were stored as triglycerides inside fat cells, especially around the liver and intestines, what we call visceral fat. At that time, visceral fat was not harmful. It was life-saving. Without it, humans could not have survived repeated periods of hunger. But during the last 200 years, everything changed. Refined sugar became abundant. Processed foods became available everywhere. Instead of fasting regularly, many of us now eat from morning until late at night. To understand what happens next, imagine that your body has 3 energy tanks. The first tank is the glucose circulating in your blood immediately after eating. The second tank is glycogen, stored in your liver and muscles. The third tank is your stored body fat, especially visceral fat. These systems overlap, but the body generally relies first on blood glucose, then glycogen, and finally, increasingly on stored fat as fasting continues. The problem is that if we keep eating every few hours, insulin remains elevated and the body has little need to draw on the third tank. So the visceral fat gradually accumulates. Many people think visceral fat is simply stored energy. It is much more than that. As visceral fat enlarges, it becomes metabolically active. It releases inflammatory molecules that cause low-grade inflammation all over our blood vessels, affecting especially the blood vessels of heart, kidney, and brain, leading to heart attack, kidney failure, and stroke. The excess fatty acids released from visceral fat interfere with insulin signaling in the liver and muscles, thereby increasing insulin resistance. The pancreas compensates by producing even more insulin. Higher insulin makes it more difficult to mobilize stored fat. Now a vicious cycle begins. More visceral fat, more insulin resistance, more insulin, more visceral fat. Most people think insulin only lowers blood sugar. That is not true. Insulin is also a powerful growth hormone. After eating, insulin rises and activates an important pathway called mTOR. I like to call mTOR the body's chief construction officer. It tells cells to grow, build proteins, repair tissues, and store energy. Without mTOR, children would not grow and wounds would not heal. Growth mode is essential, but evolution never intended us to remain in growth mode all day, every day. When food becomes scarce and insulin falls, another pathway becomes active. This is AMPK, which I call the body's chief energy manager. AMPK tells the body, stop building for a while, use stored fuel, repair what already exists. One of the remarkable processes that increase during this state is called autophagy, the cell's internal housekeeping system. The word autophagy literally means self-eating. That sounds frightening, but it is actually one of the healthiest things your cells can do. Imagine your garage. If new furniture arrives in your home every day, you don't have time to throw away or repair old and broken furniture. Eventually, the garage becomes full of broken and useless items. When deliveries stop, you finally have to clean, repair, and recycle. Autophagy works in a similar way inside our cells. It removes damaged proteins and worn out cellular components, helping maintain cellular health during prolonged fasting. Why does this matter? As we grow older, damaged proteins slowly accumulate. Oxidative stress increases. Mitochondria becomes less efficient. DNA damage gradually accumulates. If maintenance systems cannot keep pace, cells begin functioning less efficiently. Scientists believe that impaired autophagy contributes to several age-related diseases, including neurodegenerative disorders, metabolic diseases, and possibly some cancers. So, where does cancer fit into this story? Cancer is a complex disease with many causes, including genetics, smoking, infections, environmental exposures, and aging. However, many large studies have shown that obesity and insulin resistance are associated with a high risk of several cancers, including cancers of the breast, colon, liver, pancreas, and endometrium. Scientists believe that chronic inflammation, high insulin levels, altered growth signaling, and changes in immune function may all contribute to this increased risk. That does not mean fasting cures cancer or that insulin alone causes cancer. It means that maintaining good metabolic health may be one important part of reducing long-term risk. Our immune system is always watching. Every day, millions of cells divide inside our body. Occasionally, mistakes occur. Most damaged cells are repaired. Some undergo programmed cell death. Others are recognized and removed by the immune system. This process is called immune surveillance. Special immune cells, including natural killer cells and cytotoxic T cells, continuously patrol the body, searching for abnormal cells. Most of the time, they eliminate these cells long before they become dangerous and cancerous. Cancer develops only when multiple protective systems fail over many years. Now coming to the end of my talk, I would like to say that the greatest tragedy of metabolic disease is that it develops silently, long before blood sugar rises, long before diabetes is diagnosed, long before a heart attack occurs. The body may already be developing insulin resistance. The pancreas compensates by producing more insulin. Blood glucose often remains normal. HbA1c may still be normal. The patient feels perfectly healthy, yet important metabolic changes have already begun. Therefore, finally, I would like to suggest everyone to check for insulin resistance, especially if you are overweight or obese. This can be easily done by finding out an index known as HOMA-IR, which means homeostatic model assessment of insulin resistance. For this, you need to give your blood sample in empty stomach in the morning. If your HOMA-IR is more than 2, then it is considered that you have insulin resistance, an early marker of metabolic dysfunction. If appropriate and under medical supervision, intermittent fasting may help improve metabolic flexibility and reduce insulin levels in some individuals. Remember, the goal is not starvation. The goal is to allow the body to periodically switch from growth mode into maintenance and survival mode. Perhaps the future of medicine lies not only in developing better drugs, but also in understanding the biology that shaped us over millions of years. Thank you for watching. Stay healthy, stay curious, and never stop asking questions.